Hey guys, welcome back. This is lab number 3. We're going to do chromatography. So hopefully you've read your lab before we get started and you understand what's going on. We're going to be talking a little bit about how the RF factor is involved with how fast the molecules move through the medium, which in this case is going to be paper, and the solute, which it is dissolved in, how fast it's going to go through the paper, and all of the intermolecular forces that are going to either hold or allow those molecules to move through the medium and separate those out based on either size or the intermolecular forces between the molecules of the actual solvent, the solute, and the paper. So before we get started, what I want to do is show you a little bit about how we mix some of this up, some of the lab techniques that you won't get to do here in lab, but I want you to see it. So here we have 0.5% by mass solution of FD&C blue number 1 food dye. And so if you would, you can go ahead and research how many different FD&C colors are there, how many approved. So how many of those have been approved? You can research that for the use in our foods and cosmetics. So food, drug, and cosmetic, that's your FD&C. What are the different colors and the numbers? And what do they mean? So that's kind of neat to understand that. And so we have FD&C yellow number 6. And so we're going to look at that. So how did we make this stuff? Now here's FD&C yellow number 5, and you'll find out why we're not using this. But here's how we got the 0.5%. This is 2 grams. So all of this comes in 2 grams as our units. And so if we have 2 grams of this, 2 divided by 400, well, that's going to give you 0.5%. So we would then add this in here, and oh, that would not give us the correct amount. Look at that mess. And so this, we would dissolve this. But our problem with FD&C number 5 is that in water, it doesn't dissolve very well. A lot of this is going to stay undissolved, so its solubility is very low. It's going to be less than 5%, and so we're probably not going to use FD&C yellow number 5 as one of our colors here. Onward to our solvent. Now our solvent, or our mobile phase solvent, we are going to be using a 0.1% sodium chloride solution. So you kind of have to bear with me on this. So what we have here is 2 grams of sodium chloride. Okay, so there we go, 2 grams of sodium chloride. We've already measured out 200 milliliters of distilled water. So if I was to put this in here, that's going to give me a 1% solution, right? And so in lab, this would be made up for you. And so we would dissolve this. Luckily, sodium chloride dissolves pretty well, pretty quickly. So this, at this point, is a 1% solution. So how do I get to a 0.1%? So it's kind of a serial dilution. Serial dilutions, we can take 90 milliliters of distilled water. And then what I would want to do is get 10 milliliters. What you didn't see is that I had already rinsed this once with salt solution, so it is salt only in there. There we go, there it is. And so then if I add 10 milliliters of the salt solution to 90 milliliters, this is now a point. After that has been mixed, I will mix that later. Then I have 100 milliliters of 0.1% solution of sodium chloride. Why did I only mix this amount up? I mixed this amount up because I'm going to only use about 25 milliliters in each of these containers as we put it in there. If I put too much in there, it'll go above the line. So one of the next things we do is we get our filter paper cut out, and we've got our 2 centimeters line with a pencil already made, and we're going to practice just dipping in here and making tiny little dots. And so if we just touch that, that's going to be a tiny dot. Now that is not very much material, and so we would want to dot this more than once. We don't want to push down and crush the paper. We want to just barely touch the paper. And so one of the little tricks, if you'll notice, I did not do anything to this toothpick. One of the things we can do is to take this toothpick and just barely break the end of it off, and it makes it a lot larger surface area, and it kind of gives some fibers there that will act more as a paintbrush. And so now we can dot with it just a little bit more, but you don't want that dot to be much bigger than that, about half the size of a pea. And then if you were to allow that to dry, we'll let it dry, because if you dip it and it's wet and it's still wet, it's going to expand. So what you don't want to do is let that expand too much, especially if it gets down here where the water is, it's going to go into the water and make a mess. So we would let that dry and then come back over the top of it. Okay, I don't know if it's dry yet or not. As long as it's dry, it won't expand, and then we can get a higher concentration of this material here. So if you look, if I continually just keep dropping this, it's going to get bigger and bigger and bigger. But if I allow it enough time to dry, my dot should not be getting bigger. And it'll be more concentrated there. Okay, so we're back, and we're going to start making our chromatograph paper, starting with our FD&C colors. We're going to start with FD&C red food dye number 3, and so we'll do, this is labeled as R3 for red number 3, R40 for red number 40, Y6 for yellow number 6, and B1 for blue number 1. And so here in just a second, all of these should be dotted up. Okay, so we have this. We're trying not to touch this as much as possible so that these materials, the oil on our fingers, doesn't get in the way. So now we need to turn this and staple this so it will go into the beaker. Okay, so now we have our paper, and it has all of the 4 dots on here. I've got 25 milliliters of the 0.1% sodium chloride solution in here. I will place this in here, making sure that that water is not touching the dots. If it was to touch the dots are, that material is just going to go out into the water and it'll be all over the place. So if we put our line too far down, that would be a problem. And so hopefully you're going to see here just in a moment that this water is going to go up, and the dye will start to move with it. Some of it will move faster, some of it will move slower. So obviously this red 3 doesn't move quite as fast or as easily as the red 40. Get past this, Mark. The yellow number 6 seems to be working well. And somewhere we got a couple little tiny dots of blue dye somehow on our paper. But the blue is moving very, very well. Notice all of that at the bottom, almost all of it, is trying to move away. There's not much blue down there, okay? And so what we're going to do is, so that the water doesn't evaporate faster than it moves, we're going to put something on the top of this. And so saran wrap will do, but we're going to use something called parafilm. And I believe we've used some of the parafilm at some point in time before. I'll put that on the top so it doesn't evaporate too fast. So I've got the parafilm on the top so that the water doesn't evaporate too fast. Notice that some of that yellow number 6 isn't going quite as fast as the water, and so that makes a decent view for you. We're going to let this run for a little while, and then it will we'll let it dry, and then we'll start looking at some measurements. In the meantime, I will do the 4 different food colors over here. Here are the 4 food colors. I will do the same thing here with food color blue, food color green, food color red, and food color yellow. And I will develop that one. And then we will do the Kool-Aid colors. We will do the lemon lime, the grape, and of course strawberry. And so afterwards, I'll get all of that done and ready. And then the next clip should be a lot of the chromatographs. Just wanted to show you here on the food coloring, whenever I had these papers laid out, the blue FD&C blue dye number 1, which comes in a super fine powder, whenever I was mixing this up, I was mixing it up in the vicinity of the paper that we're using for the chromatograph paper, and it did get some blue in there. So that is some error, that just that blue dye, whenever it come out of this bottle, it come out as a fine, super fine powder into the air. So that's what you're seeing there. It's not something that was in the green. Now there's going to be some blue into the green food coloring because yellow and blue make green. But the stuff off to the sides, that is from the dust. So please don't interpret that any other way. Okay, so it's been about 15 minutes since we started this chromatograph. This is our original with the FD&C colors. One of the things we want to make sure we keep an eye on is the solvent. We do not want it to get to the very top because then it runs out of space. So we want to make sure we stop this and take it out before it reaches the top. Otherwise, we would have to start this all over again. So what I've done to stop it is just took it out of the solution and just set it here on the parafilm so that it can dry out. Then we can start doing some measurements. All right, so here we are. We now have our developed dried chromatograph. And so this is our FD&C red 3, FD&C red 40, FD&C yellow 6, and FD&C blue number 1, and how they developed out with the saltwater solution. And so if we are looking at measuring these, we will use first the ruler and see just how far, and I used a pencil to mark, and you can see it, I think, but I went ahead and used a pencil to mark this. We want to measure just how far the solvent traveled. So I'm getting probably a 7.50 centimeters for the distance of the solvent. The solute to the tip edge, if you wanted to do it that way, then I've got 1.30. Now, if you're going center mass, I've kind of marked where the center mass is, so you could also go to there, and that could also be measured at 0.70. So whenever you put together your tables, you can either do both of them, or you can do just one. Again, this is for the solvent. This is 7.41 maybe. The tip for the red 40 is 4.20. Center mass is 2.90. For the yellow 6, I have the furthest it went, 7.42. I have the tip is 5.20. And probably center mass is somewhere in here. This is just a guesstimate. I'm going to say it's about a 3.80. For the blue, we're going to see that the blue traveled 7.50. The very tip is 7.50. And if we did this center mass of the depth of color and the average of it, then I would have gotten about a 7.10. Moving to the food colors. Now these food colors, we're looking at this. Well, if we match these up, we're going to see, look, well, the blue, our blue had a little bit of yellow in it, a little bit of red, probably not red 3, but oh my goodness, does it match up with the red 40? Tiny bit of yellow. The blue, FC food coloring, the Kroger food coloring had blue in it, probably had a little bit of red 40, and a tiny bit of yellow. Not this kind of yellow. It's probably that yellow number 5 that we could not get dissolved very well. And then we had the green, blue and yellow make green. And so, again, not the same kind of yellow. Food coloring red, well, I don't think that it's red 40. Maybe this is a different color of red in your food coloring red, because it didn't just quite match up, did it? And food coloring yellow, notice it does have a tiny bit of red in it though. And this is a little bit lighter red. Maybe that is. If I'm looking at that, I'm thinking that's a little bit of red number 3. So just eyeballing these things, it kind of helps us to understand what we're probably going to get as a result from our math. And so if we're looking at how far it went, this one traveled, let's say 8.00 centimeters. The blue itself probably traveled about 7.50. Okay, this yellow traveled at the very tip. Both of these traveled about the same, so about 6.5 here. In this blue, it almost looks like this blue pushed that yellow out of the way. I don't know if you can see that. As it was traveling, maybe it was a heavier molecule, moved those other lighter molecules of yellow out of the way. And so that could have happened. The little red here is, we're going to say 4.20. That center mass, if we did the center mass instead, is a 2.70. Again, the blue over here on FC food coloring green, the total amount went, we were going to say 7.90. The tip is going to be 7.90. The center mass is going to be 7.55. The yellow is going to be at the tip is 6.78. And then the center mass is going to be about 5.55 again. In this food coloring red, the total distance is going to be 7.95. The tip is going to be about 7.75. And the center mass, I keep hitting the stand here, is going to be about 6.35. Over here in our food coloring yellow, again, I think these little dots here were not part of the yellow. These came from some of the contamination. And so here we go. Again, the travel is 8.00. The very tip of the yellow is 6.65. And the center mass, if you wanted to do it instead, is 5.60. So for our Kool-Aid and strawberry, we're going to see these match up. This one definitely looks very similar. In our grape, well, purple for grape, blue and red. So is it going to be this one or this one? So I don't know that it looks like, the color looks a little more like the red 40 instead of the red number 3. The yellows still just don't match up, do they? So again, if we did this, we may want to include a yellow number 5 and see how well it would match up instead of yellow number 6. We just can't get the yellow number 5 in our lab to ever dissolve well enough to get any results. But somehow other people do, because I think that's what that is. All right, here we go. So for our strawberry, and I made a couple of different places and I kept marking it as it wasn't completely dry. And so that's why you see several marks here. So if we're going here for the strawberry, the solvent traveled 6.60. The very tip of the red traveled 4.50. and the center mass is 3.30. For the lemon lime, making green, we had blue and yellow. Again, these two little dots are probably contamination. So here we've got centimeters here for the solvent, 6.60. The very end of the blue is 5.45. Center mass is probably about 5.20. The yellow, the very tip, is 3.90. The center mass of that yellow is 3.15 centimeters. Okay, for the grape, we had a total distance of the solvent traveled 6.60. The tip of the blue, again, if you're doing these in these tables, the tip is can be one column, and then the center mass for the blue can be another column. So you can do two different RF factors and see how that works for you. Or you can just throw one out if you don't like one. So here we go. The tip of that blue is, we're going to say 6.05. And then the center mass of this blue is, we're going to say is, I didn't make that mark very well. I'm going to make that mark at about 5.50. For the red here, we're going to make that at 2.95. And center mass, we would say 1.90. So those are your data points. Put that into tables and be able to calculate your RF factors. And then that way you can fill out your Google Docs, your Google form, and submit that as part of your lab. If you have any questions, email me, but you have to have this video to fill out your Google Docs. Good luck, and I'll see you on the next one.